Hey guys, let's talk about evaluating functions and function notation. So, given the function g of x equals 3x minus 7, evaluate the function when we have these pieces down here. We'll get to that in a second. First off, let's talk about what this is. This is what we call function notation. So it says g of x equals 3x minus 7. And again, that is g of x is how you say that. So here's kind of what's going on. You're more traditionally used to probably y equals 3x minus 7. It still is representing the exact same thing, except instead of y, we like to put this g of x. So what's going on is this g, this letter, that's just giving it a name. So this function is my g function. Like down here, I have an f function. So it's just a way to name each equation and each function, just like how you and I both have a name as well. The x is just showing, hey, here's what variable or independent variable in the function is. Okay, so this is what we call function notation. So this is my g function, 3x minus 7. So we need to evaluate the function when we have g of negative 3. So this looks a little bit different. Now, I often in class I'll ask kids, notice what are the big differences between what you saw up here and what we're writing down here. And what we look at is, well, what changed? Well, we used to have an x inside the parentheses. Now we have a negative 3. So we used to have an x. Now we have a negative 3. So our x is negative 3. So what we're going to do is on the right side of this function, the right side of the equal sign, we're going to make our x be a negative 3. So what I'm going to do is I'm going to plug in here. I'm going to substitute. Instead of writing 3x minus 7, I'm going to plug in a negative 3 here. So 3 parentheses negative 3 minus 7. So I could type that into a calculator just like you see it there. 3 times negative 3 minus 7. And you would get negative 16. And I could do the same now with this next one. So I have g of 4. So instead of having an x inside my parentheses, I now have a 4. So my x needs to become a 4. So my equation, I'm going to substitute, replace all x's with 4's. So this is going to be 3 parentheses 4 minus 7. So you could type that in a calculator, parentheses and all, 3 parentheses 4 minus 7, which you're going to get 5. So that's evaluating those functions. Now towards the bottom, I'm going to change things up a little bit. So we're given a new function. This is my f function because, well, it has an f here. F of x equals x divided by 4 minus 7. We need to solve for x given f of x equals 11. Now, a lot of kids just immediately try and rush into it like, okay, we're going to, x is equal to 11, plug in 11, done. That's not what's going on here. We're telling you f of x, this function, is supposed to be equal to 11. So the function f is supposed to be equal to 11. Right now we have f of x is equal to x divided by 4 minus 7. Notice I have f of x here, I have f of x here. When it says f of x equals 11, anytime I see f of x, I can plug in 11 in that exact same spot. So anytime I see f of x, I can take this 11 and plug it right in. So up here, I really have an equation with some pieces on the right side, some pieces on the left side. On the left side, I see that f of x. So what I'm going to do is I'm going to take that 11 and I'm going to plug it in right there. So I'm going to replace my f of x with 11. So this will look like 11 equals x divided by 4 minus 7. And all I would need to do is solve that for x, because that's what we want to do. So especially if it's asking you to solve for x, we wouldn't be plugging this in for x. That doesn't make sense. So solving this for x, I have an equal sign there. So we're back to real basic algebra 1. We're going to add 7 and add 7. So 11 plus 7 is 18 equals x divided by 4, because I have a minus 7 plus 7, that's 0. I need to get rid of this division by 4. X divided by 4, we're going to multiply by 4 on both sides. 4 times 18 is 72. And on the right side, when you're multiplying and dividing by 4, that divides out to 1. So we're just left with an x equals 72. So a little bit different here. Don't just plug in the 11 in for x and just start going away. Really pay attention to, are we supposed to be plugging in for x like we did up here, or are we setting the equation equal to a number like we did down here? And that was evaluating functions in function notation.